Under normal conditions, 1000 millibar, water boils at exactly 100 degrees Celsius. If the atmospheric pressure drops, so does the boiling point. At the summit of the Matterhorn at 605 millibar, water boils at just 87 degrees Celsius. On Mount Everest, at as little as 72 degrees. On our neighboring planet Mars, the atmospheric pressure is only 10 millibar. Water here would boil at a mere 7 degrees Celsius. Let's look at an experiment. The beaker contains water at 100 degrees Celsius. The air pressure is 1000 millibar. When we reduce the air pressure, the water begins to boil and the temperature drops until a new pressure balance is reached between the water and the environment. If we reduce the pressure again, the process is repeated. Under outer space conditions, the water would freeze. One practical application of this basic thermodynamic principle is vacuum cooling of bakery products. At predetermined intervals, the transport system delivers a batch of hot bakery products into the vacuum chamber. The entry port is closed, the pumps are switched on, and the internal pressure drops. Immediately, the hot, moist products begin to produce steam, and their temperature begins to drop. The vacuum pump extracts air and water vapor from the chamber. The steam is eliminated by the condenser. A rehydration process at the end of the cooling period partially compensates for the water lost from the products. The time needed to reach the required final temperature is only about 3 to 6 minutes, depending on the product. The cooled products can now be cut and packed, and the vacuum chamber is ready for the next batch. What actually happens inside the product during vacuum cooling? As soon as the air pressure drops, water vapor is released, and the core temperature of the product sinks. The flow of steam through the outer layers cools the crust rapidly. And so the temperatures of the crumb and the crust converge during the vacuum cooling process. In this way, the product is cooled from inside to outside, much more evenly and quickly than by conventional cooling techniques. After cooling, the rehydration process almost balances out the water loss, so that the products have the desired moisture content for optimal quality and freshness.